Welcome to this lesson on the segment addition postulate and the angle addition postulate. The segment addition postulate says if 3 points are collinear, which means they're all on the same line or line segment, and B is between A and C, then AB plus BC equals AC. So basically, this segment plus this segment equals the whole segment. All right, so let's look at some examples. So if DF equals 10 and DE equals 7, what is the length of EF? All right, so the whole line segment is 10, has a length of 10. DE has a length of 7. So we want to find EF. So of course, using the segment addition postulate, we know that 7 plus whatever the length of EF is equals the whole thing, 10. So subtract 7 on both sides. So the length of this would be 3. All right, next one, if MO equals 32, so the whole line segment MO has a length of 32, we want to find the value of X. So if we add these two pieces together, MN and NO, that should give us the length of the whole segment, 32. So we just need to solve for X. All right, so we have like terms, 2X and 3X is 5X. We can subtract 7 on both sides. And I'm going to run out of room, so I'm going to bring the rest of the equation up here. So 5x equals 25. Divide by 5 on both sides, so x is 5. All right, number 3, if RU equals 59, so the whole line segment is 59, we want to find the length of TR. So we know that 7 plus 3x minus 4 plus 4x equals 59. So basically these three. So it works for multiple segments too. It doesn't just have to be 2. All right, so we have like terms. 3x and 4x is 7x. And then 7 minus 4 is 3. I'm just going to rewrite it so that my variable is first. And then we're just going to solve the equation. So we're going to subtract 3 on both sides, which is 56. And then divide by 7, which is 8. Now be careful, that's not our answer because the question says find TR. That means the length of TR. So we want to find this. So we know that x is 7, so x is 8. So 3 times 8 minus 4. That would be 20. And then 20 plus 7, so TR equals 27. All right, and then the last one, solve for x, and then find the length of each segment. So we know that the whole length is 10x plus 5, and we know that we have these 3 pieces here. All right, so we have like terms on the left, x plus 3x, that's 5x. All right, so I'm going to subtract 5x from both sides. And then subtract 5 from both sides. So 10 equals 5x. Divide both sides by 5, so x equals 2. So solve for x. And then we want to find the length of each segment. So this one would, of course, just be 2. X plus 15, so 2 plus 15, that would be 17. And then 3 times x, so 6. And then if we add all those together, 2 plus 6 plus 17, that would be 25. All right, and then the last one, complete the proof. So we're given that JK equals MN. So basically this piece and this segment are the same length. Number 2 says JK plus KL equals JL. So JK plus KL gives us the whole thing JL. That is the segment addition postulate. All right, and then the next one says MN plus KL equals JL. So basically I've taken this and substituted it for MN, and I can do that because they're equal. So if two things are equal, I can substitute one for the other in an equation and it still keep that equation true. That's called the substitution property of equality. All right, go ahead and pause the video now and complete your 2 practice pages. And you can check those with your teacher, and then we will do angle addition postulate. Okay, so the angle addition postulate says if B is in the interior or inside of angle AOC, then the measure of AOB plus the measure of angle BOC is equal to the measure of angle AOC. So basically this angle plus this angle gives us the whole angle. Another way to look at it is if this angle was 20 degrees and this angle was 25 degrees, then the whole angle, you would just add those together, the whole angle would be 45 degrees. All right, so let's try some examples. If you're given pieces of information in the problem and you have a diagram, make sure you label your diagram as you go through. So the measure of angle JKL, that's the whole thing, is equal to 105. And you can draw a little arrow out just to make sure you remember it's the whole thing. And then MKL, this piece here, is 55. And we want to find the measure of JKM, so we want to find this. So of course we know that X plus 55, if we add those together, that would give us the whole thing of 105. So we can just subtract 105 minus 55. And that gives us 50 degrees. So the measure of angle, you can also write it like this, the measure of angle JKM equals 50, since I just added that X in the problem. All right, another one, the measure of DEF, so the whole thing, is 85 degrees. DEG is 3x plus 8. And FEG is 2x minus 3. So those two pieces added together should give us the whole angle 85. So we have an equation here. We need to combine like terms. 3x and 2x, that's 5x. 8 minus 3 is 5. Then I'm going to subtract 5 on both sides, so 5x equals 80. And then 80 divided by 5 is 16. And you could, of course, substitute 16 back in and find the actual angle measures if the problem asks for that. All right, next one. The measure of angle MNO is 15x plus 6, so that's the whole thing. And we want to find the degree measure for MNO. So we know that the two pieces, this piece and this piece, added together should give us the whole thing. All right, so let's see, I'm going to combine my like terms on the left side, a negative 4 plus 20, that's 16. Then I'll subtract 14x from both sides. Subtract 6 from both sides, so 10 equals x. Now it doesn't ask us to solve for x, it asks us to find the measure of MNO, so I'm going to substitute that back in here. So 15 times 10, that's 150, plus 6 is 156. All right, the measure of angle GHI, that's the whole thing, is 16x plus 7. And we want all three degree measures. So these two pieces added together equals the whole thing. I have like terms on the left, so I'm going to combine those. 4x plus 7x is 11x. Then I'll subtract my 11x from both sides. All right, so 57 equals 5x plus 7. Subtract 7 from both sides, so 50 equals 5x. Divide by 5 on both sides, so 10 equals x. And I'm just going to substitute 10 in for all three expressions. So 4 times 10, that's 40. 7 times 10, that's 70, plus 57, that's 127. And then you can just add those together to get your final 167. All right, and then the last one is a proof. So we are given that the measure of angle AEC is equal to the measure of angle BED. So basically, this is equal to this. The measure of angle 1 plus the measure of angle 2 gives us the measure of angle AEC. That's the angle addition postulate. Those two pieces give us the whole angle. And the measure of angle 2 plus the measure of angle 3 gives us BED. Again, same thing. All right, the measure of angle 2 plus the measure of angle 3 equals the measure of angle AEC. All right, so the reason I can do that is because these are equal here. So I can substitute one for the other. So that's called the substitution property of equality. All right, and then the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And I can do that because I know these are equal. So I can say that these are equal. That's the transitive property of equality. All right. Just so I can explain it a little bit better, so we know that this and this are equal to the same thing. So then we can say that they are equal to each other. That is the transitive property. And then for step 6, it looks like we have just subtracted the measure of angle 2 from both sides, which you can do and still keep the equation true, so they cancel out. That is the subtraction property of equality. All right, you can go ahead and stop the video now and complete your practice.